Hello everyone. As part of training an LLM, we have seen what do we mean by pre-training in the previous session. Now we shall see what exactly is fine-tuning. Before that, just have a look at what exactly is training of large language models. I have explained this in the previous session. It starts with data collection, then tokenizing the data, then pre-training. This is what we have seen in the previous session. Now we shall see what do you mean by fine-tuning. This is the later stage of pre-training. Fine-tuning means once the LLM learns the language, what we are trying to do is under supervised learning methodology, we are trying to see whether the LLM can do a specific task. See, in pre-training, it was like a generalized training of the language. Now, under fine-tuning, you are checking whether the model can do a specific task or the learning is now towards a specific task. So, we will try to concentrate on what is fine-tuning. It is the process of adapting a pre-trained model to perform a specific task by further training it on task-specific labeled data. What is the meaning of this? Already the model is pre-trained with the language and the data, everything. Now you are trying to make sure the model is working towards a specific task. I understood language, for example Telugu. Now you are trying to see whether I can perform a specific task of translating an English transcript into Telugu, whether I can write a Telugu paragraph if you have given me a topic. So you are trying to see, after learning a specific language, whether I can do a specific task in the language that has been trained during the pre-training phase. Unlike pre-training, which provides model with a general understanding of the language, what is fine-tuning trying to do? It is trying to refine the model's knowledge to excel at particular application. So you are trying to see whether it can do a specific task. Unlike generalized training, it has learnt during pre-training. Now you are making sure it is performing the given task, right? Now what are the key points about fine-tuning? It works with task-specific training. So fine-tuning involves task-specific training. Task-specific training means somebody has learnt a specific language. Say for example, you have learnt French, right? As part of your language skills, you have learnt French. You have learnt the entire language. Now I will ask you, can you give me birthday wishes in French? So what happens to your learning process? You have learnt the entire language. Now you are able to apply that to a specific task, right? I don't want you to speak entire French language. I am asking you, can you give me birthday wishes in French language? So the entire learning is now directed towards one specific task, fine tuning, right? So fine tuning involves training the pre-trained model on a specific task such as sentiment analysis, machine translation, classification, all these things. The moment you are trying to go for a specific task, the data set narrows down, right? When you are talking about pre-training, you are learning the entire language, the data set is vast. When I am working with a specific task, the data set narrows down, right? Supervised learning, fine-tuning is a supervised learning methodology. It works with labeled data. So it typically uses supervised learning where the model is trained on input-output pairs. What do I mean by input-output pairs? Say for example, you are trying to see the responses of social networking website. Somebody has posted something and people started responding on that. Can you classify the response of the person? Yes, you wanted to find out the sentiment behind the response. Is somebody happy with the post? that is posted on the networking site, or is somebody not happy, somebody is non-reactive, or somebody is not, doesn't want to talk on that. So what is the response meaning? So with every response you want to attach what is the emotion of that response. So we call input output pairs. The model learns to map inputs to correct outputs based on the examples it sees during training. So suppose somebody has given this, for every WhatsApp message these days we are seeing various reactions. Whatever message we post, suppose somebody says this one, either you are acknowledging that or you might have liked that. So you are trying to associate whatever input message was given, somebody has given a response to that. So the response becomes input to us and the output will be what is the category of the response, right? Then preserving pre-trained knowledge, fine-tuning leverages the general language knowledge acquired during pre-training. As I kept on mentioning, during pre-training we are learning the entire language. During fine-tuning you are trying to acquire whatever knowledge you have acquired during pre-training, we are trying to use them during the fine-tuning phase. The pre-trained weights are adjusted slightly to adapt to the new task, allowing the model to benefit from both the general knowledge that it has learnt during pre-training as well as task specific knowledge which it is trying to gain during the fine-tuning phase. What is the meaning of that? With every word we have learnt, with every sentence we have learnt, we associate a weight. Now we are trying to adjust the weights so that I get benefit from both the knowledge I have learnt at a vast level under pre-training and the narrowed level domain which I have tried to learn during the fine-tuning mechanism for a specific task. Then what is efficiency feature of fine-tuning? It is much faster and requires less data. We know that because pre-training working on entire language, vast amount of knowledge, whereas fine-tuning is working for a specific application. So it obviously requires less amount of data, less amount of knowledge. It starts with a model which already understands the language at high level. Often fine-tuning on a relatively smaller data set can produce strong results. See, it has learnt a specific language. It's like, as I told in the example, you learnt language French. That is huge. Now, my question is, can you give me birthday wishes in French? My entire knowledge of French is now narrowed down to birthday wish. The data set is comparatively lesser. So fine-tuning sometimes gives you, fine-tuning most of the time gives you strong results because it is working on a smaller data set. Customization, as we know, learning a language is at a broader perspective. Working with that language for a specific application gives you customized results, customized application working. So you are trying to customize using fine tuning and you are trying to answer the questions whatever the application demands. So in summary, fine tuning tailors a pre-trained LLM to specific task by refining the knowledge with labeled data. It works with supervised learning mechanism. Quickly, let us see some of the applications of LLMs. These are not the limited applications. I have just jotted down some of the application areas. We know it can generate new text. We are working with, these days we are seeing the examples of working with ChatGPT, which keeps on generating the content. You can ask a question, it gives you an answer. You are not happy with it, you can ask it to regenerate. It gives the answer in another perspective. You can ask a question, can you explain this to a 10-year-old kid? Can you explain this to a 20-year-old boy? Can you explain this to a 50-year-old man? Likewise. So same question you can try to generate in multiple ways. So it is trying to generate text. So it is used for content creation, and similarly you can use it as automatic writing assistant, right? Then natural language understanding. This is one of the domains apart from NLP. NLP is natural language processing. This is natural language understanding. Now generative AI comes into the domain of NLG, natural language generation, right? Now natural language understanding, it works with sentiment analysis. As I told, you can give a sentence, somebody is responding to that, you can try to classify what is the sentiment behind the response, right? Sentiment analysis based on the customer feedback, reviews, social media analysis, these are some of the examples. Similarly, named entity recognition. What is the meaning of this one? Extracting important entities like names, dates, etc. from a text information. Generally it happens with legal and medical documents. This is one of the areas where you are trying to recognize what is the name of the person. Try to identify all the nouns. It will try to extract. Text classification, you are trying to classify the documents, you are trying to classify the emails. These are all some of the examples for natural language understanding. Conversational AI and chatbots, another level of example for LLMs. Similarly, translation, we are working with Google Translator most of the time, without which generally we don't proceed to communicate. So machine translation is one of the applications for large language models. Text summarization, another example, right? So code generation and completion. Are we using this with ChatGPT, code generation? Maybe yes. Somebody gives you a programming assignment, you can try to see what code it is trying to generate and can it complete the code that you wanted to generate. So you can try to work with this. Similarly, search and information retrieval, without which generally nothing will work out. What we are doing with ChatGPT is search and information retrieval. Medical and legal applications, they are trying to, if at all you observe, if you have gone with any of your family members to hospital, the moment we finish diagnosis and the doctor gives you prescription, they take the prescription and scan it. This goes into the database wherein it can be used for various data set creation, reading the medical data and trying to get inferences from that. For all those things, we are trying to go for medical and legal applications. Similarly, we are trying to summarize all the legal documents on the like whatever the sale deed happens, contracts, legalities, legal issues of the documents. Education and tutoring, are we using large language models? Definitely yes. We are going for personalized learning, content generation for learning. These are all various domains where LLMs are put into use. Similarly, creative applications, we are seeing this to the extent, or it has been towards the limitless activity. We are creating new songs, we are creating new pictures, AI generated images. Somebody started putting their profile pics also AI generated images. These are all creative applications. Ethical and bias auditing, again whenever you are trying to work with a language specific model, there are always chances of bias detection. Similarly, content moderation. These are some of the applications wherein LLMs are trying to make their mark, right? Some more applications might be there, some more applications are still there, and the research is going on along with LLM developments. Thank you.